Ever wondered how complex algorithms are created? The secret lies in the use of high-level logic structures. These structures are the backbone of programming languages and design methodologies, providing a framework that makes the magic happen. They help programmers organize logic and control the flow of execution in their code, enabling the creation of intricate algorithms and dynamic applications. Whether it's controlling program execution, making decisions based on conditions, or creating loops for repetitive tasks, high-level logic structures are the unsung heroes of the programming world. From the simplicity of sequential structures to the sophistication of object-oriented programming, each structure has its own unique role and significance. And as we delve deeper into the world of programming, understanding these structures becomes an essential part of the journey. So are you ready to explore this fascinating world? Dive in with us as we unravel the mystery behind high-level logic structures. Starting with the basics, the sequential structure is the simplest form of logic structure. Imagine standing in a queue at the supermarket. Each person waits their turn, then steps forward when the person before them moves. That's essentially what happens in a sequential structure. Each statement in your code gets executed one after another, in the order they appear. It's a linear, straightforward progression, and the most commonly used structure in programming. For example, if you're writing a program to make a cup of tea, you'd start with boil water, then add tea leaves, pour hot water, and finally, stir and serve. Each step follows the previous one in a clear sequence. This simplicity of sequential structures makes them the perfect starting point for beginners. They are the building blocks, the foundation upon which we build more complex structures. So whether you're making a cup of tea or coding a program, remember, sequential structures lay the foundation for more complex logic structures. Moving up in complexity, we find the selection structure, a decision-making tool in programming. Let's take a closer look. The selection structure, also known as the conditional structure, is like a fork in the road of your code. It allows your program to choose a path of execution based on a condition. The most common form is the if-else statement. Here's how it works. If a particular condition is true, then a block of code is executed. If it is false, the program skips that block and moves on, or it may choose to execute a different block of code. Essentially, it's like saying if it's raining, take an umbrella, else leave it at home. This simple yet powerful structure enables your code to make decisions, react to user input, and adapt to different situations. And so, selection structures provide our programs with the ability to make decisions. Repetition structures, or loops, allow us to repeat tasks efficiently. Imagine having to write the same line of code 100 times over. It's not only time-consuming, but also highly prone to errors. That's where repetition structures come into play. They're like the superheroes of programming, saving us from the drudgery of repetitive tasks. There are two main types of loops in most programming languages: for and while. For loops are used when we know exactly how many times we need to repeat an action. On the other hand, while loops are used when we want to repeat an action until a specific condition is no longer met. Consider this. You're baking a batch of cookies, and you need to stir the dough 10 times. A for loop is your friend here. But if you're stirring until the dough reaches a certain consistency, that's a job for a while loop. Repetition structures are vital tools when repeated actions are required. Switch structures and exception handling add a higher level of complexity and control to our code. Diving right in, let's talk about switch structures. Like a multi-directional crossroads in our code, a switch structure allows us to choose one of many paths based on the value of an expression. It's like an advanced if-else statement, simplifying our code when we have multiple conditions to check. Imagine a jukebox that plays a different song based on the button you press. Each button press corresponds to a case in our switch structure. If no button is pressed, the jukebox can default to playing a random tune. That's our default case. Moving forward, let's talk about exception handling, the safety net of our code. Exception handling structures allow our programs to catch errors in exceptional situations, handle them gracefully, and continue executing the rest of the code. It's like a stunt double in a movie, taking the fall so that our main actor, the program, can continue unscathed. Now, how does this work? We begin with a try block. This is where we place code that has the potential to raise an exception. Imagine a tightrope walker. The try block is the tightrope. If the walker slips, we catch the fall in the except block, which is our safety net. Here, we handle the exception or error, perhaps by displaying an error message or performing some other action. Finally, we have the finally block. This block is like the curtain call at the end of a show. No matter what happened during the performance, whether it went flawlessly or there were a few stumbles, the curtain call always takes place. Similarly, the finally block will run regardless of whether an exception occurred or not. So why do we use these high-level structures? They help us manage complexity. Switch structures streamline decision-making with multiple conditions, while exception handling allows us to handle errors gracefully. They make our code more predictable, robust, and easier to debug. Switch structures and exception handling make our code more robust and efficient. Procedure structures and object-oriented programming structures bring modularity and reusability to our code. Let's first delve into procedure structures, also known as subroutines. These are reusable sections of code designed to perform a specific task. Imagine you're coding a game where players frequently need to jump. Instead of writing jump instructions every time a player needs to leap, you'd create a subroutine, say jump, and call it whenever necessary. This approach not only keeps your code dry, don't repeat yourself, but also enhances readability and maintainability. Moving on, let's explore the world of object-oriented programming structures. If you think of your program as a universe, then its classes and objects are the planets and moons. A class is a blueprint defining a set of attributes and methods, while an object is an instance of a class. Consider a class dog with attributes like color and breed, and methods like bark and fetch. An object would be a specific dog, say Fido, with a particular color and breed who can bark and fetch. But object-oriented programming doesn't stop at classes and objects. It introduces encapsulation, which wraps data and methods into a single unit, keeping the inner workings hidden and safe from outside interference. Then there's inheritance, a concept that allows one class to acquire the properties and methods of another, promoting code reusability. For instance, a poodle class could inherit from the dog class, gaining all its attributes and methods, while also having its own unique traits. Lastly, we have polymorphism, which enables us to use a single type entity in many forms. It's like a shapeshifter in your code, allowing an entity to have more than one form. For example, the method bark could behave differently depending on whether it's called on a poodle object or a bulldog object. These structures, procedure and object-oriented, work together to create a cohesive, organized, and efficient code base. They separate concerns, reduce redundancy, and promote reuse, making your code more modular and your life as a programmer easier. Procedures and object-oriented structures enhance code organization and reusability. Finally, event-driven structures enable our programs to respond to user actions. It's like a party where the guests are the events and the host, our program, reacts to each guest's actions. Quite the social butterfly, isn't it? These structures are the lifeblood of graphical user interfaces and interactive applications. Imagine clicking a button on your screen. That click is an event, and the code that runs in response is part of an event-driven structure. Your program patiently waits, listening for these events to occur, ready to leap into action when they do. For instance, consider a simple button click event. The code for this might look something like a function that's called when the button is clicked. Inside this function, you can define whatever action you wish to occur. So the next time you're clicking around on a website or app, remember there's an event-driven structure working hard behind the scenes. Event-driven structures give our programs the ability to interact with users. High-level logic structures, as we've seen, form the backbone of complex algorithms. These structures, in their diverse forms, ensure a smooth and efficient flow of control through our programs. From the linear simplicity of sequential structure to the decision-making prowess of the selection structure, each serves a unique purpose. We've also seen the power of repetition structures, which allow us to perform tasks multiple times with ease, and the versatility of the switch structure that facilitates multiple conditions. Exception handling structures grant our programs the grace to deal with errors, while procedure structures lend us the ability to compartmentalize our code for increased readability. The object-oriented programming structures introduce us to the world of classes, objects, and inheritance, and the event-driven structures make our programs responsive to user interactions. Understanding these structures is a giant leap towards mastering the art of programming. Happy coding!